Hi everybody, it's science time. Science time, science time, it is science time. We'll observe and experiment during science time. Science time, science time, it is science time. Reading books and careful looks are part of science time. Science time, science time, it is science time. Documenting and lots of thinking is part of science time. Hey Buster, you want to say hi to everybody? There's Buster. Say hi. Today we're gonna do some bubble science. Okay, Buster? First, I'm just gonna pour some water in this cup, this glass. There's water. How could we make bubbles? What do we need to add to the water to make a bubble? What if we use a straw? So before you use the straw, I want you to practice. Hold your hand in front and practice blowing out. Do you feel your air on your hand? We want to blow out. We don't want to suck in. So we're going to blow out for our bubble science today. So when you blow out, you can feel the gases, right? The air coming from your body. What if we add that air to the water? Let's try it. What do you see? Bubbles. Do they last very long? They don't last very long, do they? They go away. Look how fast they go away. When we add gas to a liquid, we can make bubbles. Let's add some soap. So I've got some dish soap. Don't need very much. Now let's see what happens. Oh wow, look. oh, it's very windy here. Wind's gonna blow the bubbles away. Do the bubbles last longer when we added soap? Yeah, look at that. Look how long they're lasting. What else do you notice about bubbles? Do you notice anything else? Look at your bubbles. I'm seeing rainbows in some of my bubbles. That's called iridescence. Because it kind of comes and goes. Bubbles are iridescent. That's from the sunlight. You're seeing rainbows. Experiment I want to show you. So I've got sharp, pokey things, like a pencil and scissors, and then something not sharp, soft, pom-pom. So I'm going to make a prediction. What can pop the bubble? Sometimes bubbles just pop on their own, right? Eventually they do. The water evaporates and the bubble goes away. Or something else might pop it. But sometimes we can pop them, right, with our fingers. Ever popped a bubble? So my guess is sharp, pointy things can pop bubbles. And soft things can't. Let's see. We're going to give it a try. Put the soap on my plate. Oh, yep, that popped it. Let's see the pencil. Oh, the pencil pops them. The scissors, the pointy things definitely popped it. Now let's try this. Wait a minute. Can you see? It's popping them. Even the soft thing is popping the bubbles. So what I thought, it wasn't what I thought would happen. I thought this wouldn't pop them, but the sharp ones would. But they both do. I'm gonna try something else. I still have some bubble solution in my glass. I didn't pour it all on my plate. So I'm going to try something else. I'm going to put the all the things in the soapy solution first. Let's make our bubble. Okay, gotta do it quickly before it pops on its own. Look! I'm able to put it through. Do you guys see that? It wasn't popping. Let me try the pencil. Okay, let's try the pencil. Oh. The pencil's going through the bubble. It's not popping it. Look at that. So I wonder if it's dry things that pop bubbles. This is still dry. Look, dry things pop bubbles. Pop. My finger is dry. I'm going to get the pom-pom wet. Let's see if we can get... Ooh. There it goes. Didn't pop it. Nope. I can put the pom-pom on the bubble. It's not popping it. Isn't that amazing? Dry things pop bubbles. Wet things, you can put wet things through bubbles. Try your finger, put a finger through bubbles. Try other things. See what pops and what doesn't pop bubbles. It's also fun to catch bubbles in your hands. You can try dry hands, and maybe you can do this outside. Get your hands wet with the soap solution. I'm gonna see if I can catch a bubble. Let me see, I gotta make one up high. Okay. Oop, that one popped. It's a little hard here because it's windy. Oop. I can't get a bubble. Well, you can try this at home. Oh, one landed on my finger, on my hand. Not my finger, my hand. And if you can see it, it's a little baby one. Try dry hands and wet hands. See if the bubbles pop or not on your hands. Anyway, that's bubble science. Have fun exploring with bubbles, making them pop and not pop. Oh, before we go, I have one more experiment in case you don't have a straw and you wanted to try a different way. Just a second, let me show you. You can find an empty plastic jar, fill it with water, and this step's important. You just pour a little bit of soap in. Oop, doesn't have to be much, but you don't shake it. You just pour it out. I'm gonna pour it in some dirt. This way, you get a bunch of bubbles inside. And now you can try poking them again. You can try the experiment. Let me see if I can dry my pencil. See if I can pop the bubbles. It popped. Pop, pop. Now I'm gonna make it wet. I'm gonna make, since then you can see if you can put the pencil through the bubbles. Oh, I can. And I see those pretty rainbows again. Look, there's one. I'm going right through one right now. So here is another way. And if you guys can see, but it's going through bubbles and it's not popping them. Here is another way to do your bubble science. I like doing it in the bottle. It's really fun to see. Let's see. Let's try the scissors. They were dry. I just dried them. They're popping it. Now I'm going to put it in the bubble solution. Get them nice and wet. Oh, my bubbles are too far. Oh, here's some at the top. Oh yeah, it went through one. It's moving them around, but it's not popping them. Bubbles! Popping bubbles! Bye, everyone! See you next time after spring break. Have a good spring break. We're gonna put these objects down a ramp. But first, before we do that, I'm going to make a prediction. What I think will roll down the ramp and what things will slide down the ramp. So I'm going to, I could draw them, I could trace around them. I'm going to trace around them. I think this is going to slide. I think the crayon's gonna slide. This was something. I think the bell's gonna roll. I'm gonna draw all these things that I think are gonna roll and slide. That's my prediction. Okay, now I'm gonna set up my ramp, and if it rolls, I'm gonna put it on this sheet. If it slides, I'm gonna put it on this sheet. Set up our ramp, or an inclined plane. A ramp or inclined plane has one side higher up than the other. Let's see what rolls and what slides. Put it under the... Okay. Let me test. Ooh, what about a Altoid container? Did that roll or did that slide? That slides. Slide. Let me try the bell. I thought it would roll. Wait a minute. Was that what I thought would happen? It slides. I thought it would roll. Okay, let's try this. This is a sweet gum seed pod. That rolls. I'm gonna put that under roll. Could keep going. I thought this would slide. Let's see. That rolls. The crayon rolls. You can keep doing this as much as you want. See what rolls and what slides. Older children can probably just hand draw or even write the word. If you've got lower elementary students, they could write the word if they're writing. 2-year-olds, instead of even tracing, which would be hard for them, maybe they could just draw the colors. Like if they think that's gonna roll, they could just draw the color of it. And if they thought the Lego was gonna slide, they could just draw the color. So kind of go with what the child's able to do with documenting. Roll versus slide. It's can be kind of a hard concept, but the more they do it and the more you talk about the differences, you can even do rolling, a circle, rolling with your hands. They could even roll their bodies, slide their bodies. You could talk about when they go down the slide, how their movement is. So roll versus slide. And then you could also later talk about what goes faster, things that roll or things that slide. What did you notice? I have something I want to show you. I'm gonna rub this straw. We gotta count to do 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. What's the straw doing? It's moving. Am I moving it with my hands? Am I touching the straw? it's going this way. Is it going towards my hand or away from my hand? It's attracted to my hands. This is static electricity. Static electricity. This is a variation to the straw. You can, I don't know, use something plastic like a spoon, and static electricity experiments, you definitely have to practice. It depends on the weather, how it is inside, the environment around you. Is it cold? Is it dry? That's the best. If there's a lot of moisture in the air, it might not work. The materials you rub make a difference, so you have to practice these ahead of time. Make sure you have the right materials that work. Okay, let's count to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's see if this works. Whoa, it worked really well. So I think I lost my static electricity already. Oh, there it goes. So that's another variation. And I'd like you guys to think about how you could turn these into more of an experiment. What could the children do to test more things? What I think is most fun about doing science with young children is how easy it is. You don't need much. It's easy to find things around your house to do it with. All you need is a spray bottle of water and a sunny day, and you can have them look for rainbows. So I wouldn't tell them this. I would just give them a spray bottle and have them go around and see if they can find a spray around all over, see if they can find a rainbow. And then you can ask them after they found the rainbow, where is the sun? Is it behind you or is it in front of you? To get a rainbow, the sun has to be at your back and the water in front of you. So you could try to guide them to see if they've made that discovery. If they need a little help, you can ask them some questions so they can figure out how they saw the rainbow. So yeah, you need the sun at your back and the water in front of you. But I would have them spray around, especially if it's a nice warm day. Let them spray and have fun. And then once they find the rainbow, ask them more questions. So just have them spray. You guys will be able to see, but I found my rainbow right there. There's the rainbow. You can also do it with a hose. Let's try it with a hose. Actually, you get really good rainbows with a hose. Look at that one. See that? Yeah, you get good ones with a hose. So hoses are even better, but they love, walking around with a spray bottle too. So. And you can try changing, the spray, the amount of water. What if we add more water? Would we get a better rainbow? Okay, rainbows. So other things you can do with rainbows are bring out prisms, have glasses of water by a sunny window with white paper on the ground and see if they can get a rainbow. So basically the water acts like a prism and breaks up the colors of the light. So. When I was a little girl, this was a toy everybody played with, the sound. Tin can telephones. But it really demonstrates sound really well. So, and the concept that sound can travel along the string. So, you could use tin cans, or what I've done in class is you could just get regular paper cups and a necklace string. That works. These usually can break a little easier, but they last. This one's lasted for a while. Kind of depends on your cups you use. I've made them out of here, and you can have them test. Like you could do different cups, could be your test, or maybe you use different strings. So yarn versus, this is more of that necklace string. I've even used even more ropey material. The trick with these is it has to be tight. And again with this, so that you have to tell them to make sure it's tight, but not too tight that they break them. But they have to be tight when they use these. So each person on one end. And another tricky part, especially for the younger they are, is having them realize somebody has to be talking and somebody has to be listening. But once they get, they'll get practice and explore it. They'll get a hang of it. And then they can do experiments to see where does the sound travel the best on? Which thing does the sound travel the best on? But even before that, you can ask them what's happening when they first try it. What do you think's happening? And some of the older children they'll start to say, it's amazing what they'll come up with. They'll talk about the sound going along the string. They get it pretty quickly. So the sound's traveling along the string. So sound traveling the string. If it's not tight, I think what's happening, the sound is not traveling on the string anymore. It's going away. But if you have it nice and tight, it'll stay travel along the string. So the person can hear it really well on the other side. So, sound tin cans. I have this bottle. What's inside the bottle? Some of the children will say nothing. You might have some children say air, especially if you've been doing air experiments. There's air in there. Remember, we can't see air, but it's all around. What's going to happen if we put this in cold water? Let's watch the balloon. What's the balloon doing? It's moving. What's going to happen if we put it in the warm water? Oh my gosh. It's filling up the balloon. What's in there? I can feel, it feels like air. Look, it went back down again. What do you think the cold, icy water is doing to the air inside the bottle? I think it's changing the temperature. I think it's making it cold. Maybe. What do you think the warm water is doing to the air inside of the bottle? And it's making it rise again. Warm air rises. You can do this experiment when you're doing air, or you could do this when you're doing meteorology. The reason we get hurricanes and tornadoes has to do with different temperatures of air mixing together. The different temperature of air is the reason we get our weather. And we can talk about hot air balloons. We use heat to heat the air so that they rise, and then we cool the air to make it come back down. So another fun thing you can do with a bottle and a balloon. Now, you always have to be careful if you have younger children. I've seen 3-year-olds try to put the balloons in their mouth, so you definitely have to be careful. Let's see. They love this, and this is fun to do when you're doing air experiments, or talking about air, is putting balloons on bottles and having them squeeze. What's happening to the air when you squeeze it? If you squeeze harder, will it look different than if you squeeze just a little bit? If you squeeze really hard, like that. So, really young kids like doing this. So again, just be cautious about safety.